Hello everyone, this is Dr. Surya. So today we are going to see some of the solved GATE questions. This question is from 2019 Environmental Engineering GATE question. So let us see the question first and then I'll solve it off. So the question is, raw municipal solid waste collected from a city contains 70% decomposable material that can be converted to methane. And the water content of the decomposable material is 35%. And elemental analysis of the decomposable material yields the following mass percent. And they have given an equation. Okay, then the methane production of the decomposable material is governed by the following stoichiometric relation, and a relation is given like this. Okay, so and they have given the atomic weight. C is equal to 12, H is equal to 1, O is equal to 16, N is equal to 14. And the mass of methane produced in grams round off to 1 decimal place per kg of raw MSW will be. So this is a question given to us. So don't get panic by seeing the question. So they have given that there is a city is there, and in that city they have collected the raw municipal solid waste, and it is containing 70% of the decomposable material, and that material is converted into methane, and the water content present in that decomposable material is 35%. Okay, and they have given the mass percent of carbon, hydrogen, oxygen, nitrogen and other materials present as, and they have given the ratios for each and everything, and they have given some stoichiometric relation and all. So don't get panic by seeing this, and it is going to be very easy to solve, and they have given the atomic weights also. So what we have to determine is, we have to determine that mass of methane produced per kg of raw municipal waste. That is, in simple, I can say that in 1 kg of waste, that is, in 1 kg of waste, how much or what will be the mass of methane in grams? Okay, this is what I have to find out. Okay, so how to determine this? Okay, I am going to tell you, or I am going to teach you one empirical relation that you can remember. So in that you can determine not only the mass of methane, you can also determine the mass of carbon dioxide and water too. Okay, so the empirical relation will be CaH4OCND plus A minus B by 4 minus C by 2 plus 3 by 4 H2O, which gives out A by 2 plus B by 8 minus C by 4 minus 3D by 8 CH4 plus A by 2 minus B by 8 plus C by 4 plus 3D by 8 CO2 plus DH3. So how to remember this equation? This is going to be very simple. So if you see the first stoichiometric relation, it is going to be CaHbOCND. You can write as such. Then that will give out. So you have to remember, try to remember only this value, that is A minus B minus 4 minus C by 2 plus 3D by 4 H2O. Okay, this is for water. Now just multiply, the denominator should be multiplied by 2, and you have to reverse the sign. Okay, plus sign and minus sign. So if you take here, this is going to be A by 2. Okay, this becomes A by 2 here, and this becomes B by 8, and this is going to be C by 4, and this is going to be 3D by 8. So what we have done, we have just multiplied the denominator by 8. Okay, and what we have done is that this minus sign has changed into plus sign, and the last plus sign has changed into minus sign. That's it. That is for methane. And if you come back to it, so if you come back for carbon dioxide, it is also going to be the same thing. So see here, A by 2, B by 8, C by 4, 3D by 8. So what we have done is that only the sign has changed. Plus has changed into minus, and minus has changed into plus, and again this minus has changed into plus. So in this way you can remember it very easily. Only thing is that you have to remember A minus B by 4 minus C by 2 plus 3D by 4. So this is an empirical relation, and you can remember it off very easily. Now we'll go back and we'll solve the problem. So what is given in the problem? So they have given that in 1 kg of waste, Okay, in 1 kg of waste, there is going to be 70% is decomposable. So this is what is given in the problem. So which means in 1 kg, 700 grams is decomposable. Okay, this is understandable. So 70% of 1 gram, which is 1 kg is 1000 grams, right? So in 1000 grams, so you are having 700 grams is decomposable. And if you take what is going to be the dry decomposable waste. So dry decomposable waste can be found out using, okay, so if you 1 kg is there, in that 1 kg 0.35% is taken as a water content. This is what is given in the problem, and this 0.35, that is they have given in the problem 35% as water content. So 1 minus 0.35 into 700. So this gives you 455 grams. So the dry decomposable waste that is present here is going to be 455 grams. Now what we have to do is that we have to get the value of methane. So methane consists of, so we are going to determine, so what is the moles of carbon, what is the moles of hydrogen, what is the moles of oxygen, and what is the mole of nitrogen. So because if you see here in this, so Ca, Hb, Oc and Nd, that is what given. So which means I have to get the value of this A, B, C and D. So A, B, C and D is going to represent the moles of carbon. A is going to be representing the mole of carbon. B is going to represent the mole of hydrogen. C is going to represent the mole of oxygen. And N is going to represent the mole of nitrogen. Sorry, D is going to represent the mole of nitrogen. So I am going to determine the value for A, B, C and D. Okay, so already it is given in the problem as atomic weights is given, that is for carbon it is going to be 12. So which means, okay, which means 1 mole is equal to 12 atomic mass, or simply I can say 12 is for atomic mass, okay, that is 12 for gram. Okay, so 1 gram will be equal to 1 by 12. So carbon A will be equal to, that is mole of carbon A will be equal to, okay, so which is going to be, if you take C in the problem, they have given 44 as ratio. So you could, so see here they have given C as 44, see the ratio is given as 44, and that is mass percent is given as 44. For hydrogen it is given as 6. And for oxygen it is given as 43, nitrogen is 0.8. So this is what we are going to use in the problem. Okay, so in order to determine the mole of carbon, I am going to use this 44%. So 44% is available, that is the elemental analysis of the particular decomposable material, it is containing that particular mass percent. So now, since 44% is given, I will be taking it as 0.44 into, already we have determined that 455 as dry decomposable waste and atomic mass is going to be 12. So if I just divide it, I will be getting the mole of carbon that is present is 16.68. Okay, that is my A value. Similarly, mole of hydrogen, that is going to be B. So B is equal to, already we have seen that mass percent is going to be 0.6%. So which is 0.06 into 455 grams is going to be dry decomposable waste divided by the atomic mass of hydrogen is 1. So which gives me 27.3. Next I am going to determine mole of oxygen. The value of mole of oxygen is going to be C, and the mass percent is 43%. So which is 0.43 into dry decomposable waste is 455 divided by atomic mass of oxygen is 16. So which gives me the value of 12.23. Next I will determine the moles of nitrogen, that is going to be my D value. So here they have given the mole of nitrogen value as 0.8. So which means 0.008 or 0.8 divided by 100 into 455 is going to be dry decomposable waste divided by atomic mass is going to be 14, and it gives me the value of D as 0.26. So what I have done, I have determined the value of A, B, C and D, that is mole of carbon, hydrogen, oxygen and nitrogen, which is A is equal to 16.68, B is equal to 27.3, C is equal to 12.23 and D is equal to 0.26. So why we are determining all these A, B, C, D value is that already I have told that we are having an empirical relationship, and for that empirical relationship we have to determine the value of A, B, C and D. I'll show you the empirical relationship once again. So if you see for methane, we are having the empirical relationship as, see, CH4 is methane. So A by 2 plus B by 8 minus C by 4 minus 3D by 8. This is going to be the mole of methane. That is, out of 1 mole of decomposable matter, how much methane is going to be evolved. So this is the one we are going to determine. Okay, so for this only we are going to use this empirical relationship. Suppose they have asked, out of 1 mole of decomposable matter, how much carbon dioxide is evolved, means we have to use this empirical relationship. And likewise, if water, means we have to use the other relationship. So in one particular empirical equation, you can determine the value of methane, carbon dioxide as well as ammonia. That is, if you only determine the value of D, easily you can get the value of ammonia. Okay, now we will get the value for the methane evolved. So out of 1 mole of decomposable matter, the methane evolved is, as such I have told, we are going to use that empirical formula, A by 2 plus B by 8 minus C by 4 minus 3D by 8, and we have determined all our A value, B value, C value and D value. So just apply here. So A value 16.68 by 2 plus 27.3 by 8 minus 12.23 by 4 minus 3 into 0.26 divided by 8. So if I do here, I'll get the methane value was 8.61 moles. Okay, now what is 1 mole of methane actually? So if you take here, which is, if you take 1 moles of methane will be equal to, so for carbon the atomic mass is 12 and for hydrogen the atomic mass is 4, but you are having 4 hydrogen here, so 4 into 1. So you will be having 16 grams. So 1 mole of methane will contain 16 grams. But if you take for this particular problem, how much grams per kg of municipal waste they have asked. So the methane evolved will be equal to 16 into 8.61, which is equal to 137.76 grams per kg of municipal waste. So the answer is 137.76 grams. So simply we can fill in the blank as 137.76 grams. Thank you and happy learning.